Alright, in this video, I am going to show you how to use the exponential models. And the first thing you need to know is that we can have a growth or a decay model. And we use this when a real life quantity is going to increase or decrease. So for example, money in your bank account or the value of your car. If you have a growth situation, you would use this basic model and then you would put in the appropriate information. Usually time is the variable and y is the output. And you can have a decay model, and notice that the only difference is whether you have a plus sign for growth and a minus sign for decay. A is always your initial amount. R is your percent increase, but you're going to express this as a decimal. So for example, if it's increasing 3% per year, you would do that as 0.03 would be the decimal. Or if it's increasing by 30% every year, then R would be 0.3. Another way to think about it is moving the decimal twice over to the left and turning it into a decimal. 1 plus R is known as the growth factor, or 1 minus R is the decay factor. And this is actually the same thing as your base, right? Because that's what's being raised. Notice that it's in parentheses to your exponent. So it's your base or your multiplier. Same thing here. So here's an example of a growth situation. In January 1993, there were 1,313,000 internet hosts. During the next 5 years, the number of hosts increased. So we have a growth situation by 100% per year. And this is the percent growth. Write a model giving the number H in millions of hosts per year, per T years after 1993. So you start with the base model, y equals a, 1 plus r to the t. We know this is going to be H in millions. This is the initial amount. The initial amount is 1 million. But since we want to give the answer in millions, we're going to divide this by 1 million. And we're going to get 1.313. Right, we don't want to, when they say per millions, that means that you get a number and you multiply it by a million to get the actual value. So A is 1.313. We know that R is going to be 1, because 100 over 100 is 1. So we have 1 plus 1 raised to the t. And t is the variable, so that stays like this. So let's see if we can rewrite this. This is H equals 1.313. What's 1 plus 1? 2 raised to the t. This is the model. About how many hosts were there in 1996? Where time was 0 in 1993, what's the time 3 years later in 1996? Well, 94 is T1, T equals 1, 95 is T equals 2, and 96 is T equals 3. Another way of doing this is 1996, 1993 is 3. So T equals 3. And you plug it in. H equals 1.313, 2 raised to the 3. And you get that H equals 10.504 millions. Or both answers are acceptable. Graph the model. Okie dokie. In graphing the model, I'm trying to find out where I'm going to fit this. Let's see. There is no k, so y equals 0. B equals 2, right? And that means that it's greater than 1, so it's going to be growth. A is positive, so that means it's regular growth. 0 comma A, what's the A value? 1.313, right? So this is going through 0, 1.313. This is that asymptote that is going to approach on the left, and the model pretty much looks like this. Use the graph to estimate the year where there were 30 million hosts. So they actually wanted us to plot points for this one. So let's see if we can plot some points. Let me see. Time, age. We know when t equals 0, we have 1.313. When t equals 3, calculated here, is 10.5. And so now we want to do something like 5, 10. All right, I'm going to pause the video. I'm going to calculate these. All right, when I use 5, I get 42. So that's not good. So let me try 4. 1.313, 2 raised to the 4th. I get 21. So it would be somewhere between 4 and 5 years that we hit 30 million hosts. So between 4 and 5 years. So 4 years and something is when we hit 30 million hosts. All right, this one is a decay model, and you buy a new car for $24,000. The value Y of the car decreases by 16% each year. So right here it's telling you that the value is decreasing, and even if they don't tell you, the value of cars decrease. And you have to write an exponential decay model. So we know that Y equals A 1 minus R to the T. Y is going to stay Y because the value Y. A is 24,000. We can leave this as 24,000. 1 minus R. What is R? R is 0.16. Remember, 16 over 100 is 0.16. So 1 minus R. And then T. So the model is going to be Y equals 24,000. 1 minus 0.16. 0.84 to the T. That's A. B. Use the model to estimate the value after 2 years. So when T equals 2, Y equals 24,000, 0.84 square, and then you use your calculator. So you should be using your calculator right now. $16,934 in some cents. That's how much a car is worth after 2 years. Then they want us to graph the model. So since we use the graph to estimate, I'm going to go ahead and plot my points first. All right, so when time was 0, I know the car was worth 24,000. When time was 2, I know it was worth 16,934. So I'm going to do 3, 4. Pause the video and calculate this. All right, so at 3 years is 14,224, and at 4 years is 11,948. So if obviously the answer is going to be this, all right, you just go ahead and you plot these points. 0 is 24,000. 1, 2, 16,000. 3 is 14,000. 224. And 4 is 11,948. So it's a decay model that kind of looks like this. And you would be able to see that around time equals 4, it's 12,000.